Today's lesson is about functions. What are they? Your learning target says, I can identify relationships that are functions and ones that are not. To understand what a function is, we have to start at the beginning, and that involves this word relation. So a relation explains any association between sets of data. So you might think about my grade book. Each of you has a grade for the last assignment. That pairing of data, your name and your grade, that's a relationship. If you give me the name, I can give you the score, and vice versa. In relations, the pairs of names and grades are ordered, which means one comes first and one comes second. Usually relations are shown as ordered pairs. Now, in the past, you might have called the first number in a relation a lot of different things. Maybe it was the input or the x value. This year, we're going to call it a domain, but in the past, you might have called it a starting value. The second number in a relationship also could have been called several things. In the past, it might have been the output or the y value. This year, we're going to call it a range. In the past, it might have been the ending value. So what makes a function special? It's a relation, but in this case, the domain has one and only one range. If that is not the case, it is not a function. So I want you to think back to my grade book. Each person has one and only one grade for the last assignment. The relation of student to grade is a function. But let me show you this example. Maybe we have Susie Sunshine and Kind Ken and Nice Ned and Patient Patty. All right, on the last assignment, Susie got 96%, Ken got 98%, Nice Ned, he got 84%, and Patty got 96%. So let's say Mr. Beam comes in and he's got a paper and it's Susie's paper and I forgot to write her grade on it. I could tell him exactly what her grade is because every domain in my grade book has one and only one range. There is only one grade for Susie for that assignment. But let's switch it around. Let's say the domain are the grades. In this case, something bad's going to happen. So I had an 84%, I had a 96%, and I had a 98%. And those grades belong to Susie and Ken and Nice Ned. I forgot to write his name. I just called him Nice, and Patty. Now, if Mr. Beam came in with the other situation, he had a paper, and the paper was a 96%, and he wanted to know, who does that belong to? I could not tell him with 100% accuracy who it belonged to. If it had been the 84 paper, I would have said it belonged to Nice Ned. If it had been the 98 paper, I would have told him it belonged to Kind Ken. But the problem with this one is it could either be Susie's or Patty's paper, and because there's that confusion, that vagueness, this cannot be a function. It is just simply a relation. The function needs to have one domain, one range. And when you have a domain that goes to two different ranges, that's a problem. So this one is a function, and this one is not a function. So let's see how to determine whether a relation is a function using ordered pairs and a table. So the first thing I want you to do is I want you to identify your domains. The domains, remember, those are the first numbers or the x values. So I'm only going to write them once, even if they're repeated. So I have -5, 3, and 1. I'm not going to write that 3 a second time because that'll just mess me up. Then I want you to identify your ranges. Those are the y values, so that's 2, 3, 7, and 0. And then we're going to map them. So in other words, negative 5 maps onto 2, and 3 maps onto 3. And 1 goes to 7, and 3 goes to 0. To decide if I have a function, I look at each of my domains. Does each of my domains only have one range that is possible? Or is there a problem? And I believe there is a problem. The problem would be, well, first of all, this is not a function. And my reason is because domain 3 has 2 ranges. That can't be, so it is a relation, but not a function. All right, let's do the same thing down here with our table. So I want you to identify your domains. So I have an 8, a 1, a negative 5. I'm not going to write that 1 again because that's going to mess me up. And a negative 10. And my ranges are negative 2, 3, 7. I'm only going to write it once, otherwise I get messed up. And 13. Then I'm going to map them. 8 goes on to negative 2. 1 goes on to 3. Negative 5 goes on to 7. 1 goes on to 7. And negative 10 goes on to 13. So what do you think? Is this relation a function, or is it not a function? This is not a function. The problem is that domain 1 has 2 ranges. To be a function, each domain can only have 1 range. Another way to determine if a relation is a function is to use something called the vertical line test. And so you're going to move a pencil or straight edge from left to right. So let's say that here is my graph. There's my graph. And I would hold a pencil or a straight edge vertically going up and down, and I would move it from left to right across the graph. If the pencil passes through no more or intersects with no more than 1 point on the graph, then we're good. We got a function. But if that vertical pencil passes through more than 1 point, then we've got a problem and it is not a function. The reason this works is because remember that graph is made up of ordered pairs. Every x can only have one y. And if we don't pass the vertical line test, let's say we had this graph, although it's lovely, it is not a function. The problem would be right here. All of those x values that x value shares many y values. That's a problem. And this x value shares many y values, and that's a problem. And that's why the vertical line test works. We're not quite done with vocabulary yet, but these are things that we've talked about in the past, just not necessarily called them by these names. So a function rule is the operation performed on the domain value to get to the range value, also known as the equation. A function table organizes the domain, rule, and range. So sometimes we use T-charts, X, Y. Sometimes we use H-charts. We have X, we have the rule, and we have Y. It's just a way to organize ourselves. Now here, this is important. We have a dependent variable. The value depends on something else, and it is the Y value. Not that it depends on the Y value, it is the Y value. The independent variable, that's the X value, and it does not depend on anything. So if I had an ordered pair, I'd have the independent variable followed by the dependent variable. All right, we're going to walk through one of these together, and then you have 2 to do on your own. Make sure that these are in your interactive notebook with the other notes from this presentation. So we're going to use this rule. We're going to double the sum of 3 and a number. So we are going to double 2 times the sum of 3 and a number. Okay. Excuse me. So it says to choose 4 different domains. Now you can choose any domains that you want, but you're going to end up graphing them and you have to calculate them. So I would be easy on myself. I tend to like 0, 1, 2, and 3, but you can pick anything you want. So if the domain is 0, I would simply plug 0 in for x, and my output would be 6, or my range would be 6. If my domain was 1, I'd plug 1 in where x was, and my range would be 8. If my domain was 2, I'd simply plug 2 in where the x belongs, and my range would be 10. And if my domain was 3, I would plug 3 in, and I would get a range of 12. So, at this point, we could list our domains. We had 0, 1, 2, and 3. Our ranges were 6, 8, 10, and 12. When we map them, 0 goes to 6, 1 goes to 8, 2 goes to 10, 3 goes to 12. This is a function because, as you see, every domain has one and only one range. All right, your turn. I want you to use this rule. 5 more than twice the number. Choose 4 different domains. Calculate your ranges. Write your domain and your ranges and decide if it's a function. Do this in your interactive math notebook. When you're done, come back to me for checking. All right, so our rule would be 5 more than twice a number. I'm going to pick the ever popular 0, 1, 2, and 3. I'm going to start plugging things in. Domain. My domains are 0, 1, 2, and 3. My ranges are 5, 7, 9, and 11. When I map them, my answer would be yes. This is a function because every domain has one and only one range. All right, last one for the day. I want you to do this one by yourself in your interactive notebook. When you're ready for checking, come on back to me. All right, so here is my function table. I chose my 4 different domains. So when I write out my domains, I had 0, 1, 2, and 3. Those are my domains. And when I write out my ranges, I have 5, 6, 7, and 8. And when I map them, it looks like we're good to go. We have a function because every domain has one and only one range.